Okay, so this question asks the point 1, negative 2, 3 lies on a sphere centered at negative 4, 5, negative 2. What is the radius of the sphere? So we know the sphere equation is x minus a squared plus y minus b squared plus c minus c squared equals r squared, as r is radius. So we are given the sphere is centered at negative 4, 5, negative 2. So let's plug in these values in the equation. So x plus 4 squared plus y minus 5 squared plus c minus c plus 2 squared equals r squared. Okay, we have the equation. Now, we also have the point 1, negative 2, 3. Let's plug it in. Let's put it in those values for x, y, and z. So this becomes 5 squared plus negative 7 squared plus 5 squared equals r squared. So r squared is just 99. Sorry. So the radius would be just square root of 99. This is equals to 3 square root of 11. So the answer is B. Okay, so this question asks to find the vector projection of W onto B. So W onto B is, you can write this into W dot B over B dot B dot B. So W is given as 2, 3, and B is 1, 2, 1 over 1, 2 times 1, 2 times 1, 2. So if you do the calculation, this is 2 plus 6, 8, and 1 plus 4, 5. So 8 over 5, 1, 2 multiplied. So this is just becomes 8 over 5 and 16 over 5, which is just C. Okay, so this question asks to find the area of the region bounded by y equals 0.5x plus 3 and y equals x squared minus 1.5x plus 3. Let's draw these curves. So 3, so like this, y equals 0.5x plus 3, and then y equals x squared minus 1.5x plus 3. So like this graph. Okay, so maybe it's not like over the axis, but like this. Okay, so we have the graph and the area. So if you want to find the area bounded by that region, you just subtract from the bigger radius and the smaller radius. You just subtract the smaller radius from the bigger radius, meaning the bigger radius would be this much, which is y equals 0.5x plus 3. So 0.5x plus 3 minus smaller radius, which is the curved line. So x squared minus 1.5x plus 3 dx, entire thing. And we want to find the intersection point. So we said equals 0.5x plus 3 equals 1.5x, x squared minus 1.5x plus 3. So 3 cancels out. X squared minus 2x equals 0. X minus 2 equals 0. X becomes 0 and 2. So the intersection is 0 to 2. I'll rewrite this. A equals 0 to 2. So 0.5x plus 3 minus x squared minus 1.5x plus 3 dx. So if you do the calculation, 0.5x plus 3 minus x squared plus 1.5x minus 3 dx. 3 and negative 3 cancels out, and this becomes 0 to 2, negative x squared plus 2x dx. If you integrate this, it's going to be negative x cubed over 3 plus x squared, integrating from 0 to 2. So this just becomes negative 8 over 3 plus 4. And this is just 4 over 3. So the answer is A. Okay, this question asks the region is bounded by y equals e to the negative x, y equals 1, and x equals negative 2. And it's revolved about the x-axis. And it says it used the washer method. Okay, so let's draw the curves first. So y equals e to the negative x, we have that. and it's at y equals 1 and x equals -2. So if you draw it, the area is this line, this much. So if you want to use the Washer method is volume equals pi, bigger radius squared minus smaller radius squared, dx or dy. So in this case, it's a revolve above the line x-axis. So it's gonna be dx. So the bigger radius in this case, in here, is this line, which is the y equals e to the negative x. So bigger radius becomes e to the negative x, and then the smaller radius becomes this much, y equals 1. So y equals 1. So if you write this equation, b equals pi, a bigger radius squared, e negative x squared, when a small radius is just 1 squared dx. And we have to find the intersection point. Oh, we don't have to actually. It's because it's revolving around the line -2. So the lower bound is -2 and the upper bound is 0. So this is pi -2, 0, e to -2x minus 1 dx. And I see that option is D. So this question asks the angle between vector A and vector B. If you see those kind of questions, you can use U, B equals U magnitude and B magnitude cosine theta. So in this case, A is our U and B is our B. So -1, 2, 2, -1, 1, 0, and vector U, vector A, and vector B magnitude and cosine theta. Let's find our vector A magnitude. Vector A magnitude is -1 squared plus 2 squared plus 2 squared. This just becomes 3. Vector B magnitude is -1 squared plus 1 squared plus 0 squared. This becomes square root of 2. So this is 3 and square root of 2 cosine theta. And let's calculate the left side. This is -1 times -1, 1. Plus 2 times 1, 2, and 2 times 0 is just 0. So 3 equals 3 square root of 2 cosine theta. And this is 1 over square root of 2 cosine theta. So theta is cosine inverse 1 over square root of 2. This is just pi over 4. So the answer is C. Okay, so this question asks find the volume of the parallelepiped with adjacent edges. Okay, let's draw PQRS points. P and Q, let's do R here, and S. P is 2, 1, 3, Q is 1, 3, 4, and R is 2, 1, -1, S is 2, 2, 5. Let's find the vectors first. PQ would be 1, 2, and so -1, 2, 1, and PR would be 0, 0, -4, and PS would be 0, 1, 2. Okay, we have everything. So when you want to find the volume of the parallelepiped, you do cross multiplying of the one set of the vectors, and then you multiply with that, you dot product with the value. So we are going to do PS dot PQPR cross multiply. So we're going to do the PQ and PR cross multiplication first. I, J, K, and PQ is -1, 2, 1. PR is 0, 0, -4. So if you do the cross multiplication, this becomes 2, 1, 0, 4, -4. I, -1, 0, 1, -4. J plus -1, 0, 2, 0, K. So this will be just 0, K. And -8i minus 4j. So this becomes -8, -4, and 0. So that's the product of our PQ and PR cross product. So let's multiply that value with the PS. PS is 0, 1, 2. So 0, 1, 2, dot product -8, -4, 0. This becomes 0, -4 plus 0, so -4. but it's the absolute value if you look at the equation. So b is just equal to -4 absolute value, which is just 4. So the answer is A. So this question asks to find the volume of the solid obtained by rotating the region bounded by the curves. So let's draw the curves first. So y equals x, y equals x and y equals x squared. So like this. And this is the region, and it's rotating around the y-axis. So we're going to use the washer method, but since it's rotating around the y-axis, you have to rewrite this equation as x equals y, and this will be x equals plus minus square root of y. But this part will be square root of y. So, okay, we have that. And if you want to use the washer method is b equals pi bigger radius squared minus smaller radius squared, and then integration. So in this case, our bigger radius is this much line, which is bigger radius is the curved line y equals x squared, which is just square root of y. And the smaller radius in this case is this line. Smaller radius is y equals x, which is same as x equals y, so it's y. Okay, so if you want to write the equation, b equals pi bigger radius square root of y squared minus smaller radius y squared dy. And this is integrating from 0 to I don't know where, so we can like set the equations, like the curves equal to each other to find the intersection points. So x equals x squared minus x equals 0, x minus 1 is equal to 0, x is 0 to 1. This is on the point for the x point, and then we want to find the y point. So y equals 0 for 0, and 1 becomes just 1. Sweet. So it's going to be pi integrating from 0 to 1, and those are the integrands inside. So pi 0 to 1, y minus y squared dy. This just becomes y squared over 2 minus y cubed over 3, 0 to 1, integrating, multiplied by pi. So if you do the calculation, this just becomes pi over 6, and the answer is E. Okay, this question asks to find the volume of the solid. So if you want to find the volume of the solid and it has a cross sections, it's just volume is same as cross section area integration. So we know that volume is the region is bounded by y equals square root of cosine x, and this is the square. Where is it? Square over there. So if you want to find the area of the cross section, this just becomes square root of cosine x squared and dx, and then it's from negative pi over 2 to pi over 2. So you just have to integrate this thing. Negative pi over 2 to pi over 2 cosine x dx. Since cosine x negative pi over 2 to pi over 2 is same as 2 times 0 to pi over 2 cosine x dx, we can just integrate this. So, and multiply by 2, basically. So 2 times sine x 0 to pi over 2. So sine pi over 2 is 1. So this just becomes 1. So 2 times 1 is 2. So the answer is B. Okay, so this question asks the region is enclosed by the curve and we want to find the volume. Let's draw the curve first. So it's y equals sine x, but it's from 0 to pi only. So this much, 0 to pi only. And the x-axis is rotating about the line. Y equals negative 1. Y equals negative 1 here, right there. It's rotating. Okay, so if you want to find the volume of this thing, we can use the washer method. So as you remember, volume of the washer method is pi times bigger radius squared minus smaller radius squared. So in here, our bigger radius is this line, right? So this line would be sine x minus minus 1. So this just becomes sine x plus 1. And the smaller radius is this line, right? Which is y equals -1. So if you write the equation, volume is equal to pi times bigger radius squared, so sine x plus 1 squared, minus smaller radius squared, -1 squared is same as 1, so just 1. This entire thing integrated as from 0 to pi dx. So if you want to find the option, which is just A, there you go. Okay, so this question has a surface area. A surface is obtained by rotating the curve and find the surface area. So surface area equation is a to b 2 pi fx or y, 1 plus f prime x y or y, dx or dy. So in our case, it's about the x-axis, so we're going to use surface area 2 pi a to b fx 1 plus f prime x dx. So we're given fx is x cubed, and f prime x will be just finding the derivative, so 3x squared. So f prime x squared will be just 9x to the 4th power. And we're given it's from 0 to 1. 2 pi 0 to 1 x cubed 1 plus 9x to the 4th dx. And let's set 1 plus 9x to the 4th as u. So u equals 1 plus 9x to the 4th. du becomes 36 x cubed dx, and then x cubed dx is just same as du over 36. So if you rewrite this, this is 2 pi du over 36, because we have this, right? So this becomes du over 36, and then square root of u. And then you're going to find the new bound. So 1 plus 90 to the 4th power is just 1. And 1 plus 1 to the 4th power just becomes 10. So this is 10. 2 pi from 1 to 10, square root of u over 36 du. So let's take out the 36 out. So pi over 18, 1 to 10, u 1/2 du. This becomes pi over 18, u 3 over 2, 2 over 3, 2 over 3, my bad. 2 over 3, 1 to 10. So if you do the calculation, pi over 18, so wait, this becomes pi over 27, pi over 27, and 10, 3 halves minus 1. So that's the answer, which is D. Okay, so this question asks, use the method of cylindrical shells to find the volume generated by rotating the curves about the line x equals -1. So let's look at the curves first. Y equals x minus x squared. Y equals x minus x squared is this. It's from 0 and 1. And y equals 0 here. And x equals -1 here. There we go. X equals -1. Something like that. And so the region bounded by is this area. So if you want to use the cylindrical shells and it's rotating about the line x equals -1, so we can just use the dx as a thickness. Shell method is always parallel to the axis of rotation, which in here it's x-axis, so which is why we're going to use dx as our thickness. And the volume for the shell method equation is 2 pi length radius dx thickness. Okay, let's find the length first. So the length is the area, like this area bounded by, so it's just minus x squared plus x. And the radius, it's the tricky one in here. Radius is this line, which is x, and then you have to do x minus 1. because it's not from 0 and it's until x equals -1. So this becomes x plus 1. So if you write the equation, b is equal to 2 pi negative x squared plus x, entire thing multiplied by x plus 1 dx, and we want to find the bounds for it, which is already given, 0 to 1. Let me draw the equation. So this is 2 pi 0 to 1 negative x cubed negative x squared plus x squared plus x dx. So this x squares are going to get cancelled out. 2 pi 0 to 1 negative x cubed plus x dx, negative x to the 4th over 4 plus x squared over 2, 0 to 1, multiplied by 2 pi. 2 pi negative 1 over 4 plus 1 over 2. This is just 2 pi times 1 over 2. So, wait, this is just 2 pi times 1 over 4, my bad. So this just becomes pi over 2. So the answer is E. Okay, so this question has to find the work done. So to find the work done when it's stretching by from a length of 2 to length of 3. Okay, so we know that force equation is the constant k times the change of length. So we are given 50n, and it's from natural length of 1 meter to 1.5 meters. So the change of length is 0.5, and then that's multiplied by k. So if you want to find the k, you divide 0.5 on both sides, and k just becomes 100. So we have the force equation, F equals 100x. Okay, and then if you want to find the work is just integrating the force equation. So work is 100x dx, and then the important thing is stretching the spring from a length of 2 meter to length of 3 meter. And its natural length of 1 meter, meaning this is 0, and this is increased by 1, this is increased by 2. So it's integrating from 1 to 2. So 1 to 2, 100x dx, this is just 50x squared. Integrating from 1 to 2, this becomes 50, 4 minus 1, 50 times 3, this becomes just 150 joule. So the answer is C.